She's been real smart.
Yeah. I don't know what
Paige, what's your GPA now?
She's evil. She has secret powers. What is it? 4.7. What? You're just saying.
Okay. Today I'm anticipating will be the first of 2 lessons. We're doing function operations. This includes addition, subtraction, multiplication, and division of different functions, as well as identifying their domain and domain restrictions. And then we're doing composition of functions as well. I'm anticipating today is just addition, subtraction, multiplication, and division. I'm trying not to overwhelm you. Try it, keyword. Okay. So before we get too far into this, we need to identify what domain is. I know we've kind of touched on it before, specifically identifying restrictions. Today, we're actually going to set up intervals of domain for each of our problems. So the domain is the set of all possible input values for the specific function. So this, in layman's terms, is every x that could possibly be plugged in and solved for in the function.
If you start with
Never start with that. Come on. Since we have a domain, we can also have domain restrictions. So these are the numbers that do not work for our function. So these are values that cannot be plugged in. More often than not, we identify these as the values that make our function undefined. Sorry, Shane, I'm trying. I have to reconfigure all of this again. Thank you, Amanda.
and then I hope people know she can't
I have my glasses on my head.
So when I say values that make a function undefined, what is the first thing that you think of? Think of anything, I guess this should be our question.
That's the up and down line, isn't it? Where's that?
Well, that would be like a vertical slope, which you can't do.
That's still
But it's kind of the same thing. I think about fractions when I think about an undefined answer. When would I have an undefined answer in a fraction?
That's the part I don't know. It's either the 0 on top or on the bottom. I don't remember which
Okay.
one. Zero.
When you have a 0 in the bottom. So the way to think about this is it is okay to have a 0 in my numerator, but it is not okay to have a 0 in my denominator.
That's smart.
Oh. It is okay to have a 0 in the numerator. It is not okay to have a 0 in the denominator. So this one, the answer is 0. This one, the answer is undefined. Because I can never divide by 0. Sam.
I thought when the 0, oh, that's never mind. That was one. I thought 0 was 1.
Anybody confused by the okay and the no?
So that one's undefined.
Yes. This one does not work. No, you can't do it. This one's okay. Does that help anybody? Somewhere in there? Okay, I hope so. That's my goal here. So this means that if I have a fraction, if I ever get a 0 in that denominator, that x value that makes it 0 would be a domain restriction, which means it could not be included within the domain for my specific function. Of course, I will show you how we set that up with domain restrictions. However, the domain restriction is important because if we don't have a restriction, we assume our domain is negative infinity to infinity. So more often than not, it is easier to find the things that don't work rather than finding all the things that do work. Okay, so if everything works, we assume it's negative infinity to infinity every single time. That is our base assumption. So since we've identified what would make our domain or our function undefined, let's talk about putting our functions together. Because I know you're so excited. So there are some rules that we have. The first rule is, I guess I clarify this better. Let's assume we have two functions, f and g, in terms of x. We assume that these are just polynomial functions, so there is nothing that makes either of them undefined. We have some rules for putting these together. The first one is, if I am taking f plus g of x, this is the same as adding f of x to g of x in their original form and combining like terms. So whenever you see something that is f plus g of x, that is the same as f of x plus g of x, so adding their individual functions together. This also applies for subtraction. So if I see f minus g of x, that is the same as f of x minus g of x in their original form. The order in which it's written here dictates the order in which we solve it here. Make sure you're following the order that your function operation is written in. So that covers addition and subtraction. We also have multiplication. It is very important here that when you write multiplication, you use a closed dot. It should be 100% filled in. You'll understand why in a little bit. A completely closed dot. So this reads f times g of x, just like with the previous examples. This is the same as multiplying the individual functions together. So that is the same as f of x times g of x. Each of these say the same thing. They're just in different notation. What operation are we still missing? Division. So this would read f divided by g of x. So this is the same as f of x divided by g of x. Again, the order in which they are written is the order in which they're put into the problem and solved. So if this read g divided by f, g would have to be in the numerator. Okay, make sure you're following the order of the problem. Any questions, concerns, or issues with any of these? Okay, so we're going to put some actual functions with it. I have a question though before we move on. Just looking at these as individual polynomial functions, would any of these have a domain restriction? What's the most common type of domain restriction that we identified? When a what occurs? Fraction. Are any of these a fraction? This is the only one, for the most part, where we are going to find domain restrictions. If there is no restriction, what do we assume our domain is? Negative infinity to infinity. So this is really the only one, for the sake of this lesson, where we're going to find some domain restrictions that we'll have to exclude. Okay? So let's do some examples with some actual numerical functions. Let's assume for these examples that we have two functions, f of x and g of x. We're going to say f of x is x squared minus 4, and g of x is 2x plus 1. For each of these next problems, we're going to be performing the operation and simplifying as far as possible. And then we're going to identify the domain for each of these simplified functions. First example A, we're going to go ahead and do f plus g of x. So the f plus g tells me what operation we're doing. The x here says that we're leaving x's in our answer. If there was a number here, I'd show you what we would do with it, but we aren't there yet. Somebody talk me through how you're going to solve this or simplify it. Sarah. Okay, what do you mean by plug it in? It's not a trick question. It's actually that straightforward, I think. I can't hear you that well, so I think you said you'd put the f of x plus g of x, right? And then you'd actually plug in x squared minus 4 where the f of x is, and the 2x plus 1 where the g of x is, and then it would become this, right? Where the first two were the components of my f function, and the last two were the components of my g function. Again, I want this in simplified form. So what am I going to have to do with those terms? Combine like terms. Is there anything I can put together? The -4 and the 1. Sometimes there's not going to be anything, and that's okay too. So this simplified is x squared plus 2x minus 3. Questions, concerns, or issues with that one?
So that's the answer.
That would be your answer for the simplified function, yes. But then what was the other thing I was looking for this? Domain. What's the domain of that function? Negative infinity to infinity, because there's no denominator that I have to worry about going to 0. So the domain for this is simply negative infinity to infinity. On your homework, you will be identifying domain for each of the problems. So make sure you just get in the habit of that.
What was that first part called? Simplifying.
Simplifying you can just say the operation of the two functions. I just say simplifying the answer because it's hard to put that into words. Okay, so we did some addition. Now let's move on to another operational example. For this one, I would like to do g times f of x. We're going to use the same properties as before, yep, and we're going to use the same functions that we already identified. So this is the same as g of x times f of x, remember, because I have to follow the order that is written in the problem, which means I'm going to have 2x plus 1 times x squared minus 4. Lila, how would I simplify this out? What do we call that? Anybody help her? What do we call that when you just distribute everything? Foiling, because it's a 2-term times a 2-term. So we're going to FOIL this out, and then we will simplify. So when I FOIL it, I get 2x times x squared is 2x cubed. 2x times a -4 is a -8x. 1 times x squared is just x squared. And 1 times a -4 is a -4. Patty, what do I do next? What order would that be then? So she noticed that there was nothing that she could combine because we didn't have any like terms, but that doesn't mean that we have to leave it written in this form because this is not in order. So she rewrote it so it looked nicer and it was in standard form going from the largest exponent down to the smallest, which is our constant. Any questions, concerns, or issues with that one? Christina, what would be my domain here? So the negative infinity to positive infinity, right? Is there a denominator here that I have to worry about? No, there's no fraction at all. It's all on the same level, which means I can plug any number into this and it's going to give me an answer. So my domain is negative infinity to infinity. Does anybody know of another way that we can write this domain without using infinities in it? Huh?
I said all real numbers.
All real numbers. So the double-walled R would also work. I prefer interval notation though. If you put double-walled R, I would count it. After a while, infinities start looking like 8s. It happens. Questions, concerns, or issues with that? I'm going to ask a 1 to 5 how we feel so far with putting functions together and identifying the domain. So 1, no idea what's happening anywhere at all. 5, you can teach somebody else how to do it. So 1 to 5, how does everybody feel so far? Wow, almost overwhelmingly. Brandon, come on, you cannot not do this. 1, you have no idea what's happening. Okay, so I'm going to call on you next. Okay, so let's go ahead and do another one. This time, I would like to do f minus g of x. I want everyone to attempt this one on your own first, and then Brandon's going to talk us through it. I can always tell when somebody's writing in infinity because when you start to do it, you always turn your paper sideways and draw the 8. I see so many people do that. It's so much fun. Brandon, you're up. Talk me through it. How did you do it?
Subtract
Okay, what did you subtract?
the x squared minus 4 plus 1.
So you just did it like this, right?
Yeah.
Is that how I'm supposed to do it? I missed something if I did it like this. What did I miss? Say that again. This is not minus 2x and then plus 1. This is minus the entirety of 2x plus 1. So that negative has to be distributed to everything inside that second function. So this one would actually become x squared minus 4 minus 2x minus 1. And then what would I do, Brandon? Okay, what would you simplify?
Make the negative 4 negative 1.
Perfect. He'd put the negative 4 and the negative 1 together, and we would get x squared minus 2x minus 5. Anybody have any major issues with that one?
Where did you get the numbers from? Like, how did you get numbers from F minus G? Oh.
Yeah, they're all coming from this.
Oh. Okay. Yeah, I did not do that.
I've just been making them up as I go, that just seems fun.
Yeah.
Okay, what's my domain for this function? Elijah. How did you know? There's no denominator to worry about, so my domain is negative infinity to infinity, or I could always just say the set of all real numbers.
We're gonna go over if there is a denominator.
Guess what we're doing next?
Follow
Yes.
the pattern.
How do I find the domain? I look for numbers that I could plug in that would work. So can you think of any singular number I could plug in for x here that's not going to work? I couldn't either, which is how I know it's negative infinity to infinity. This is always what we assume it is unless I can prove that that's not true. Okay, so I'm going to show you next an example where we can prove that is not negative infinity to infinity. So I think that was C or D. Example D, I would like to do F divided by G of X.
My G's are becoming Q's.
It happens. That's why mine get so curly after a while, because I'm worried that they start looking for something else. So this is the same as F of X over G of X. So I'm just going to go ahead and fill in what those F and G functions are. And when I do, I end up with x squared minus 4 over 2x plus 1. We're all okay with that? Fantastic. Is my domain here going to be negative infinity to infinity?
No.
Why not? What do I now have in this problem? A denominator, because I have a fraction. So, Patty, fraction was still right. Oh, I'm sorry. Miranda, you are still right. Okay. To identify what that restriction is, because I know that one has to exist because I have a denominator that has a variable in it, I need to take that denominator and set it equal to 0 and solve for that variable. This will tell me the number that makes that denominator equal 0, and that's the number I must leave out of my domain. So we solve it just like normal. Subtract the 1 over, and then divide by 2. So the only thing that makes 2x plus 1 equals 0 is if I plugged in negative 1/2 for x, which means this is the number that I have to exclude from my domain. This means there's going to be a break at negative 1/2 in my intervals. So the way I would write my domain, I would start at negative infinity. I would go to negative 1/2. I'd stop, and then I would start a new one, picking up from negative 1/2 to infinity. So because we are using soft brackets, at each of those negative 1/2 tells me that I can get infinitely close to negative 1/2, but I never actually plug negative 1/2 into this function. So my intervals are literally every single possible number except for negative 1/2. If you wanted to continue using that double-walled R, you would say the set of all real numbers except x can equal negative 1/2. That would also be an acceptable domain.
Is that flat?
It's just a straight vertical line. It's kind of like a line that says such that. I know that seems weird, but could I simplify that fraction? There's nothing I can do to that.
So if we have like a question that's like write it out like that, and then like if you can.
If you can, you should, but majority of them you will not be able to. Okay, is anybody super duper confused by the domain part? This is something, the more we do it, the easier it gets, and we're gonna be doing it for a very long time. Okay, so I don't expect that you're gonna be super duper awesome at it now, but I do expect that you will get better with it and it'll become more natural over time. Anybody confused by how I wrote either of these domain notations? I prefer this one because oftentimes we'll have more than one break, but this is acceptable. Okay? No major questions or issues or anything right now. Yes. Go. Yes. So what we're gonna do now, because I don't think we need a ton more of just simple addition, subtraction, or multiplication, or even division examples, we're actually going to plug values into these operations now, because I know that sounds super, super fun. Okay, so we're going to use those same functions just because I think they're really awesome. I'm gonna go ahead and rewrite them, that way we have them handy. Sam, thanks. So I'm still using f of x squared minus 4, and g is 2x plus 1. And then I'm solving. The first thing I would like to solve is g plus f. Solved it too. So it's written almost exactly like the previous examples have been, except instead of leaving an x in that second parentheses, I put the desired number in. There are technically two ways that we can solve these problems. I'm going to show you the easiest way and the fastest way. If you'd like to see the other, I will happily show you that as well. Just like on the previous problem, I can now separate this into the addition of the two functions individually. Again, instead of having an x, I'm going to input the number that I'm going to be solving at. So that expands into g of 2 plus f of 2. Instead of g of x and f of x. Again, maintaining the same order I was given the problem in. This g of 2 right here means I'm going to go to my g function and I'm going to plug 2 in wherever there's an x. So this becomes 2 times 2 plus 1, and then I solve that out and get a number. So what's 2 times 2 plus 1? Everybody. 5. So g of 2 is going to equal 5. I, of course, will do the same thing with my f of 2 right here. I'm going to take 2. I'm going to plug it in for the x in my f function, and I'm going to solve it out. So when I plug that in, I get 2 squared minus 4. What's 2 squared? Minus 4? 0. So f of 2 is 0. And then I would just do 5 plus 0, which is, so g of f of 2 equals 5. You don't have to worry about any domain when we're plugging in a specific value. Unless, of course, that value would not work. How do we feel about that? Yes, I prefer your answers written like this. Makes it nice and neat. Anybody super confused by that?
So is that the domain there?
We don't have a domain for this one because I had a specific x value I was plugging in. We only do domain if what's left in here is an x or the variable that we're working with. That's a great question. Ready for another one? Okay. Oh, goodness. So using that same f and g, I would like to do I know, it's so much fun, right?
Ew.
Yeah. So on this one, I would would like to do the operation 2F plus G solved at 5. This is exactly what it looks like. This 2 in front of my F says I'm going to my F function. I'm going to multiply by 2 before I plug in this number. If there was a number in front of G, I would do the same thing. Good news is I don't have to do that. So this is the same as 2 F of 5 plus G of 5. And I plug it in just like I did before. My F function is x squared minus 4. So when I plug 5 in, that becomes 5 squared minus 4. I solve the 5 squared minus 4 part first. What is that? Am I moving too fast? I can slow down. What's 5 squared? Minus 4. You did 2 times 5 instead of 5 squared. Yeah, so 5 squared minus 4 will be 21. And then 2 times 21 is going to be 42. Plus, and then I get to do all of this again with my G of 5 function. My G function is 2x plus 1. So this becomes 2 times 5 plus 1. 2 times 5 is 10 plus 1, 11. So I get 42 plus 11, which equals what? D3. So 2 of F plus G at 5 equals 53. Questions, concerns, or issues on any of that? Do you want to do some more examples, or do you want to take a look at the homework?
Why is it 2 outside of
On this side?
the other G?
Because 2x plus 1 is my function. So where the x was, I put a 5. So I just showing that we multiplied 2 times 5. Right? Because G was 2x plus 1.
Oh, okay.
So I just replaced the x with a 5, but I didn't want to read it as 25, so I read it as 2 times 5. Okay, we're going to take a show of hands. Who would like to do some more examples? Nobody. Wow. Who wants to do their homework? Okay,
You said look at it.
you're going to do it. The homework is on Canvas. You can do everything okay, you can at least do the first half. Do not do anything. Please make sure you're all looking at me right now. Do not do anything that looks like that. Do not do anything that has an open circle in the middle. Because you don't want to yet, because you will do it wrong.
I remember seeing those.
Do not do anything that has an open circle in the middle. It is not a 0. It is not multiplication. You know how to do composition of functions? I didn't think so. Okay. Do everything else. Try to do everything else. This is technically not due until Friday. Yes, because this is a 2-day lesson. Tomorrow's Thursday.
You don't need to use half the time give me a second. Look.
Okay, kiddos online. That means that you are just going to go ahead and start working on your homework. I'm here to the end of class if you have any questions. And then after class, if you have questions, just email me.
Because I can pass it.